All right, can you see it?
We can.
Great. We start. There we go. Stop part, John. Since the first talk was focused mostly on XCMS and what we're currently trying to finish with it, I thought I'd use this opportunity to just give you a sense of related things that we've been doing over the course of the last 5 years. So 5 minutes, 5 years, 5 Metabolomics downloads. One of the first ones we came out with was in 2018. This was the MRM download. That was of 15,500 MRM transitions. And actually, that's one that gets downloaded even to this day quite frequently. It's a fairly popular one. The second one is the 80,000 molecular standard library of retention times. And again, that's also fairly popular. I hadn't anticipated at that point when we came out with this that as many people would be interested in retention time numbers given the conditions that we were using, but it's actually, like I said, has 80,000 molecular standards with retention time information. This one is a personal favorite. It's the correlated ion monitoring, and we made some original observations that on a fairly broad scale with Metlin, that we were able to see the in-source fragments matching across a wide range of molecules with the tandem mass spectrometry data. And then we ultimately applied it to a single quad where we developed a program called correlated ion monitoring that allowed us to use the in-source fragments to treat a single quad like it would be a triple quad. And get very good quantitative accuracy, very similar to what you could expect with a triple quad using a single quad. So that, again, like I said, it is a personal favorite. As I mentioned in my earlier talk, this is the converter, and I thought I'd just show a short movie that that Avanti put together as one of their molecules of the month. This is, in the simplest form, this is how the converter works. It's basically transforming the MS-MS data into what we consider a different dimension of information that you can use. And the last one is related, the last download is related to this last picture in this, which is an ion mobility spectrum. And what we've been doing recently has been using or generating ion mobility data, and we have actually just shy of 30,000 molecules right now in the database. It's about 29,500 or so, and we're going, and this is unpublished, but we're currently converting the ion mobility data into CCS values, and we're going to make that downloadable as well. I'm working with Tom Metz. We're also working with Skyline to come up with the best approach to actually do that. And finally, it's going to take us we've hit a pretty high number with the tandem mass spectrometry data. However, with the ion mobility, it's a much more time-consuming process. And 30,000 is a nice number, but it's where I doubt we'll ever get to the levels that we've gotten with tandem mass spectrometry data. It's because it's a more time-consuming process. And then finally, I'll just end with this movie right here that people often ask how we've dealt with so many molecules when we do this in generating this data. And one of the key technologies that's really facilitated this has been acoustic deposition. This is I think it's a lab site acoustic deposition device. And basically it allows us to deposit nanoliter sized droplets from our wells onto our plates, which we then, and you can shoot on to this as many droplets as you like. This is 1 nanoliter. We can put hundreds or thousands of nanoliters into one spot, and we can mix and match different wells. So it's a fairly streamlined process, and it really facilitates if you're trying to do, as we have, hundreds of thousands of molecules and analyze them in a time period of years like we have. This has turned out to be the key technology. And wow, I still have 25 seconds. So maybe what I'll say is that that molecule I showed you earlier, this is a Gary Patty molecule. Gary, I'm sure you recognize this. Oops, yeah, in this. So that this molecule was originally observed for chronic pain by Gary Patty, which was dimethylsphingosine. All right, 5 minutes and 3 seconds, 3.68 seconds.
Pro. Questions for Gary?
Yeah, was that the retention time you were mentioning? For what retention of what you just presented?
For lightning talk.
Oh.
Time for lightning talk. 5 minutes.
Okay, thank you all. What a great session. So we're heading to break, and we'll be on break until 2.